More hardware issues in Linux. In this video, we'll talk more about hardware for your Linux system. First, we'll cover some terminology, and then we'll explain troubleshooting specific hardware problems. Another topic we'll cover is running Linux on your laptop computer, and some of the special considerations involved with laptops and Linux. So let's get started. Let's start with a discussion of IDE devices. IDE stands for Integrated Device Electronics, and then there's EIDE, which is Enhanced Integrated Device Electronics. These devices are also known as ATA devices, which stands for Advanced Technology Attachment. So when I'm talking about IDE devices, I'm talking about anything with one of these three names. So Linux supports two IDE controllers, and each controller itself can support two IDE devices, so that gives you a maximum of 4 IDE devices on your Linux system. Now, a typical IDE device would be like a CD-ROM or a hard drive or something like that. Now, if you have an IDE hard drive and you think it's not performing up to par, then what you can do is you can do a test on it. You can say HDParm with the lowercase t option and then specify the disk that you want to test, like like /dev/HDA or something like that. So you'd specify this, and then it would test the disk transfer rate of that particular disk you specified. It would do a bunch of transfers and then give you some sort of summary information like the disk transferred 15 megabytes per second. Okay, and then what you do with this number is you either compare it to a previous run of HDParm, and if it used to run at 15 megabytes per second and it still runs, then you know it's okay. If it used to run at like 25 megabytes per second and now it's 15, you can suspect that something's wrong, and we'll talk about what you can do there. Now, another thing you could do with this 15 megabytes per second is just compare it to the manufacturer's specifications. So if you've never run HDParm before on this disk, this is the only number you have, like the only experimental thing that you've ever done on your disk, then you'll have to compare it to the manufacturer's specifications. So the manufacturer's specifications can be a little misleading sometimes, and you have to be really careful when you read them. Some manufacturers will advertise their disk transfer rate in megabytes per second, and they represent that with a capital B. Other manufacturers will represent disk transfer rates as megabits per second with the lowercase b. Alright, so you have to be careful when doing this. I mean, it's a uppercase b, lowercase b, you could easily overlook that, but this is a factor of 8 different in the numbers. So something that was advertised as 10 megabytes per second, this thing would have to be advertised as 80 megabits per second to be equal with that. Alright, so that's quite a difference, and you have to keep your eye out for that. Another thing you have to worry about with manufacturer specifications is whether they're advertising internal or external transfer rates. Now, internal transfer rates are what the drive can transfer, and external transfer rates are what the bus can transfer. So here's your hard disk, okay? And it's hooked up by this bus to your motherboard, and it's plugged into your motherboard, and it's transferring data across the bus. Well, typically the bus has much greater bandwidth, can transfer data much more quickly than the disk can. So usually the disk is the bottleneck in this equation. So it's like a highway, right? Like the bus is like a 6-lane highway, and then the disk is like a 3-lane section of that highway. So it doesn't matter that the 6 lanes, can pump all these cars through. They're all going to have to go through that 3-lane section, and that's going to slow things down. All right. So a lot of times you'll see manufacturers advertise external transfer rates even though they're larger than the internal transfer rates, and you'll never actually realize this in practice. All right. Other people will advertise internal transfer rates. Most drives will advertise this, but it'll be buried down on the spec sheet a little bit. This will be up at the top, prominently displayed, because it's a bigger number and it makes them sell more disks. Okay, so you just have to be a little bit careful here. And even the internal transfer rate, I mean, you're not going to get 100% of that for every data transfer. You're typically going to get like 80 to 90% of the manufacturer's advertised internal transfer rate. That's what you'll realize in practice, just because when they do the test and they say what the maximum internal transfer rate is, they've got some file contiguously laid out on the disk, so the transfer is going to be done perfectly. In practice, the files get scattered around on the disk, and there's more spinning that the disk has to do to get all that stuff. It's what we call seek time. The files have to be found and then transferred, and they're not laid out perfectly all the time in practice. So that's why you'll only see like 80 to 90% of the internal transfer rate. Let's talk about what you can do if you run into problems with your IDE hard disk. The first thing that you should try and do if you're having problems with the disk, like the disk isn't booting or the transfer rates are really bad, check for loose cables or faulty cables. If you have a spare cable that you can plug in and try in place of the cable that you have now, that would be great. That's a good first test, because a loose cable or a faulty cable could cause all kinds of problems, everything from the disk not booting to transfer rates being low, that kind of stuff. Another thing that you can try is to get diagnostic tools from the manufacturer of the hard disk. So go to the manufacturer's website and download some stuff, and that stuff will be the diagnostic tools, and it should typically all fit on a floppy, and they'll also make it so the floppy's bootable. So you can stick the floppy into your computer and boot up your system, and then it'll boot you into the diagnostic tools for that particular disk. And when you download that information onto the floppy, also download some stuff like a manual or some sort of help sheet that will guide you through the process to diagnose the problems on your disk. So this is a good tool, and this is going to be very manufacturer dependent. That's why I said get that help sheet or get that manual, because that's going to help guide you through the process to determine what's wrong with your disk. Another thing you have to check are master-slave settings on IDE hard disks. So before we saw a picture of a motherboard, and on the motherboard there was this port, this slot for IDE devices. And I told you earlier that those IDE controllers themselves can control 2 IDE devices. So typically, you know, the picture that we saw before of an IDE hard disk hooked up to our motherboard, it was just one hard disk and the cable was like this plugged into the motherboard. Well, you can also get a cable that will extend like this to another hard disk, all right? And then you can have 2 hard disks on this one port. So that's nice, because if you need lots of disks, you can plug 2 into this one port. You have to be a little bit careful, because the performance isn't going to be as good as two separate disks. So if you have 2 IDE ports on your motherboard, which most motherboards do, and you only have 2 IDE disks, you should probably just plug 1 into each port. You're going to get better performance. But if you need it, if you have like 3 or 4 IDE hard disks on your system, then you're going to have to do this chaining, we call it. And this chaining, basically what this amounts to is that the one that's first in line to the actual port is called the master, and then the one that's second in line over here is called the slave. Okay, and you need to make sure that these are configured correctly, and the way that you configure these as master and slave typically is with jumpers. So on the back of the disk drive, in between the connector for the power and the connector for the ribbon cable, is this area for the jumpers. And there's these pins sticking out like this, and you've got your jumper, and it's going to slide over some pair of these pins in this vertical direction. All right, and typically they've got something like this: MA for master, SL for slave, that kind of stuff. So you would put the jumper over these 2 pins if this was the master disk, and you would put the jumper over the next 2 pins here if it was the slave disk. And you have to make sure that's configured correctly. The first one in line's got to be the master, the next one's got to be the slave. If they're both masters or both slaves, or vice versa, if this one's the master and this one's the slave, then things aren't going to work, things aren't going to boot up, and you just need to be careful that you've set this up correctly when you add it on these hard disks. And then another thing that you can do, I've put at the end of the list because it can be a little bit dangerous, is use the HDPARM utility. There are some, besides just testing the performance of your disk, it can also fix some various issues or change some settings of your disk. It can change it from like DMA mode to PIO mode. Okay, DMA mode is direct memory access mode, and in that mode the CPU is really not doing as much stuff. It's downloading a lot of the work off to the controller itself to handle disk transfers. PIO mode, the CPU is dealing with all the data transfers. So PIO mode generally loads up the CPU more. DMA mode takes load off the CPU, and you can experiment back and forth with these, see which one's better. You can set the various levels of PIO mode. You can do all sorts of things with HDPARM. And like I said, these can cause problems, so I don't want to stress too much here that you should try this. You should really have to know what you're doing to use HDPARM, and you really need like a manual for the disk and some sort of information about how HDPARM will affect the performance of this disk. And certainly anytime you're going to use HDPARM in this mode, you should have a complete backup of your disk, a recent backup, because like I said, it could just completely damage your disk. Now let's talk about SCSI, which stands for Small Computer Systems Interface. Compared to IDE, SCSI devices are typically more expensive, and they're also higher performance than their IDE counterparts. So you just need to decide, is the extra money worth the higher performance for your particular situation? All the stuff that we were talking about in relation to IDE disks, like how manufacturers advertise the transfer rates and things like that, all that stuff applies to SCSI disks as well. So you need to look for that internal transfer rate and make sure you understand whether it's megabytes or megabits per second. just like you did with IDE disks. The thing that differentiates SCSI disks from IDE disks mostly is that the SCSI bus is very different. The SCSI controllers allow more devices per controller than the IDE controllers did. We saw the IDE controllers only allowed 2 IDE devices per controller, and for SCSI that number is 7 for standard SCSI and 15 devices per controller for wide SCSI. So that's quite a bit more. And not only does the SCSI bus allow more devices per controller, but it also allows concurrent communication. So let's draw a little picture here. So here's our motherboard, and we're going to chain together some disks. Now when that chain was IDE disks, like this would be a picture for IDE disks, there was only one transfer allowed over this bus at a time. Either device could use the bus to transfer data to and from the motherboard. Well, with SCSI devices, we can make this chain longer. Not only can we do that, but the devices all can communicate simultaneously to and from the motherboard. Okay, so that's what concurrent communication means. All these devices can be transferring data to and from the motherboard at the exact same time, as long as the sum total of the bandwidth of all those transfers does not exceed the bandwidth of the bus itself. Okay, so you're going to get good performance by chaining SCSI devices together. You're really not going to lose much performance unless you're transferring tons and tons of data simultaneously from all these various disks. Okay, so that's the advantage of SCSI. You can have more devices and you can have this concurrent communication. Now, a problem that some people run into with SCSI sometimes is that they don't terminate the chains correctly. So you've got to terminate the chains, and you've got to terminate them correctly. You've got to lay the chain out so that under any situation it will be terminated correctly. So let's talk more about termination, because that's a very tricky topic, and it typically causes errors that are a little harder to detect than some errors. Okay, so our SCSI interface here, here's like the simplest picture we could have. We've got our SCSI interface and we've got our hard drive. Now the SCSI interface is actually a device on the SCSI chain, so you have to terminate this as well as the hard drive. Both ends of the chain are terminated in this example. So let's say that stuff on this side of our picture here is internal devices, like inside the case of the computer, and stuff over here are external devices. Okay, so now let's add some stuff to this. Let's say we've got our SCSI interface again, and let's say on this side we add a zip disk, an internal zip disk, and then we have our hard disk again. And then outside here I have a scanner, and then over here I've got an external hard disk. Okay, so there's my new SCSI chain here. Now what needs to be terminated are the 2 hard drives. Not only do the 2 hard drives need to be terminated, but it really matters how this is laid out in the order here. So when I'm drawing this, this is like a physical drawing, like the SCSI device, the SCSI interface hooks up to the scanner first, and then it's chained to this hard drive. Internally, it's hooked up to the zip disk first, and it's chained to this hard drive. Okay, so that's physically the layout of your computer. All right, and these 2 must be terminated. But you know, if you flip-flop these 2, right? Say you put the hard drive first next to the SCSI interface, and then you put the scanner out here. Well, now it might seem like the scanner needs to be terminated, and it does. But if the scanner's off one day, like you just turn the scanner off or you unplug it or something, then this isn't going to work. Nothing on this chain is going to work, or there's going to be likelihood for failure, because now nothing's terminated on this side because the scanner's turned off. So you should put stuff on the ends of the chain that are always going to be on. Internal stuff is probably always going to be on because it's hooked up to the power supply of the computer, but external stuff is more likely to be turned off. So you have to make sure whatever's on the end, on the external side of things, is something that's going to be on all the time so that the termination works properly. And a hard disk is a good candidate for that if you had an external hard disk. You'd want that on the end because it's always going to be on, so if you have that terminated, everything else in the chain is going to work. All right, so that's a little bit of a tricky issue. There's also how you terminate this. That's another issue. So the termination, there's 2 choices for termination. Okay, one choice is physical. So you can have these connectors that slide over the end that actually physically terminate the chain. Or another choice is electronic termination. Sometimes this is also called smart termination. And if you read some tech journals, you'll see they spoof on this and call it dumb termination, because a lot of times this doesn't work. So what you want to be careful of is that if you use this, if you depend on this electric termination, that you try out all these various situations before. Turn stuff off on the external side and make sure everything still works properly. Okay, if you have your choice, everything that I've read says you should use physical termination. Those little things that slide over the end that actually physically terminate it. They're just much better. They're much more reliable. And then, of course, you have to lay this out. You have to be smart when you lay this out so that the devices that are always on are on the ends of this chain. Let me just talk about a couple other SCSI issues here that cause problems sometimes. One of them is the assignment of SCSI identification numbers. There's the identification numbers available for standard SCSI are from 0 to 7, so there's 8 identification numbers there, and the SCSI identification numbers for wide SCSI is from 0 to 15, so there's 16 identification numbers there. Now, earlier I told you that you could only hook up 7 devices to standard SCSI and you could chain together 15 devices for wide SCSI, but I just told you there's 8 ID numbers for standard and I said you could hook up 7 devices. Why that one discrepancy? Well, because the SCSI host adapter itself is actually a device on the SCSI chain. And so that takes up an identification number which only leaves 0 to 6 or 7 numbers for the rest of the things to hook up to the chain. So when I said only 7 things could be hooked up here, I was already calculating in that the SCSI host adapter took up one of those identification numbers. All right, so the SCSI host adapter is typically identification number 7 and a boot disk is identification number 0. So this causes people problems sometimes because they think of these numbers being the ends of the chain. So 7 is one end of the chain and 0 is the other end, and so they terminate these devices because they have ID number 0 and ID number 7. But you have to just ignore these numbers when you're thinking about termination. When you're thinking about termination, think about that physical layout and terminate the physical ends of the chain like we just did in the last slide, and then you'll be fine. Don't even think about these identification numbers when you're thinking about termination. They're irrelevant to termination. Okay? Another thing that causes problems is cable length. So the cable length, depending on your variant of SCSI, whether it's like standard or wide, now there's like ultra SCSI and all this stuff, the cable length can range from 1.5 meters to 12 meters. And I thought I saw something recently on the web that was like 25 meters long or something for cable lengths. I couldn't find a reference to that, so I just wrote 12 here. So this could actually end up being the limiting factor to how many devices you hooked up. Like if you only could have a 1.5 meter cable hanging off out of your computer here, you probably can't hook up like 15 devices to that because it would just be hard to get 15 devices all lined up there within 1.5 meters of each other to hook them all together in this 1.5 meter cable. So sometimes this is the limiting factor. You just need to determine for your variant of SCSI how many devices you can hook up practically given the cable length limitation and also these ID limitations. Let's talk a little bit about peripherals and problems you might run into with peripherals on your computer. And when I'm talking about peripherals, I'm talking about anything that hooks up to your computer, like a printer, a scanner, an external zip disk. Even like an internal hard drive is a peripheral. Even though it's inside your computer, that hard disk could easily be an external hard disk outside your computer. I guess all I'm trying to get across here is that it doesn't have to be outside of the case of your computer to be a peripheral. It could be inside. So the problem areas that I've listed here are with the device itself. And in terms of the device itself, I've already given you resources and places to look to determine if a specific brand of device is compatible with Linux. So once you determine that something's compatible with Linux, then you don't have to worry about that compatibility issue anymore. Certainly, like the circuitry in the device could fry, and you need to, get the device fixed or replaced or something like that to have a functioning device. But once you get that compatible device, you don't have to worry about compatibility issues anymore. Then there's the cable that hooks the device up to the interface, and if that's faulty or loose, you're going to run into problems. But that's easy enough to test. You can make sure that snug up the ends and see if it works, and if that doesn't work, then replace a cable from some other computer. Put it in here and see if that makes the whole thing work. Then if it does, then you'll know it's that initial cable that was bad. And then there's the interface itself, and we haven't talked too much about that, so let's concentrate on that right now. The floppy interface is built right into the motherboard. Okay, so if that goes bad, then you either have to replace the motherboard, or if you're resourceful, you could find an old 386 or a 486 card, like an ISA card or something, that has a floppy interface on the card. So you can plug the floppy drive into that floppy interface on the card, plug the card into the motherboard of the computer, and now you've got a floppy drive back on your computer again without having to buy a whole new motherboard. So coming across these might be a little bit hard as long as you don't have to pay like antique prices for them, some like collector's item price for them, then, it'll be a lot cheaper than buying a new motherboard. And maybe you're saying to yourself, well, I don't even use that floppy drive. What do I need that for if the interface fails? But you need to have something, right? Like when you did the installation process, you created that emergency boot disk on the floppy. So if your hard disk fails, at least you've got some way to boot your system, and the floppy drive is why that is still on your computer to do that in those emergency situations. The monitor port is actually on the video card itself. So you can determine what's wrong here. Like if you don't even see any text when you turn your computer on, you don't even see like the BIOS messages or anything like that, then you know something's seriously wrong. And it's maybe the device is fried, or maybe the cable's bad, or maybe it's the interface. So you can easily take the cable and the device, the monitor, off your computer, plug it into some other computer and see if it works on that computer, just to narrow down whether it's this or the interface. If you narrow down the fact that it must be the interface, then you basically have to get that fixed or replace your video card. Keyboards and mice, peripherals, they're highly standardized. Pretty much all those will work with Linux. There's not too many problems you can run into there. If the mouse or the keyboard just stops working and you plug it into some other computer, it doesn't work there anymore, you basically just replace the device. They're so cheap nowadays. You can't really replace the cables on them because the cables are usually just integrated right into the mouse or the keyboard itself. So it's just a matter of replacing the whole device, which is not a big costly endeavor. And then there's parallel ports. Again, parallel ports are right on the motherboard themselves nowadays. And if this fails, if you can't use your parallel port, which is typically used for things like printers or external zip disk, I have an external zip disk that's on a parallel port, then the parallel port, either if that fails, then you either need to replace the motherboard, or again, if you can find an ISA or a PCI parallel port interface, then you're okay. You can plug this card into your motherboard, plug your parallel device item into the port on these cards, and then you're back functioning with your parallel port again without having to replace your motherboard. And these are easier to come by than those like floppy device cards like that I was talking about for the old 386 and 486 computers. And then there's a new interface out there called IEEE 1394, more commonly known as FireWire. This is typically currently an add-on to Linux. Nobody has this built into their motherboard yet. But don't be surprised if in the future they're built into motherboards, because it's becoming an increasingly popular device because it's so fast. It's just unbelievably fast interface. And who knows, it could replace SCSI, and who knows what it's going to replace eventually. But for right now, it's currently just an add-on for Linux. Before we wrap up, I just want to talk a little bit about Linux and laptops. Basically, if you're buying a laptop with the intent of running Linux on it, you should really consult one of these websites before you do that, just so that you can see what laptops have had Linux successfully installed on them, which ones are more of a hassle, that kind of stuff. Linux-laptop.net is one site here, and linux.org/hardware is the other site. And they're both have a bunch of information about running Linux on laptops. They have user accounts of installing Linux. Usually the biggest issue with getting Linux to run on a laptop is just the display. Because these displays on laptops are these liquid crystal displays, and they're just very sensitive and temperamental. They want a particular refresh rate. They want a certain resolution they run in really well, and other resolutions they don't run in so well. So you just have to be careful. And on these websites, they have user accounts of what users have had to do to get Linux to run on various laptops, and you might be able to grab a configuration file right from one of these accounts. If they posted it, you can just grab that XF86 configuration file for the X Windows system and use it and see if that gets your display to work fine. It's better, trying to do that than, experimenting, especially if you're a novice, just experimenting through all the possibilities of the configuration settings. That can get old really fast. So that's a good resource to check through there to see if somebody's already done it on the particular brand of laptop you bought, or if you haven't bought it yet, you can see which ones have sort of the least amount of work to get Linux working on them. And laptops just have a lot of little issues with them. The modems on laptops, a lot of those, if they're software modems, you're going to have to make sure that you can find drivers for those modems if you're going to use the laptop with a modem. A lot of laptops, high-end laptops, have Ethernet cards nowadays. So again, you have to make sure that that particular Ethernet card is supported by Linux. It's just a lot of little issues, and you should just check through here before you even buy a laptop if you intend to run Linux on it, because it'll just make your life a lot easier. You won't have to experiment as much and spend as much time setting it up, and you'll just get to use it pretty much right away. Well, it's time to wrap up our second nugget on hardware issues. In this one, we really concentrated on troubleshooting hardware problems. At first, we talked about IDE and EIDE and ATA devices, and we talked about how you can string them together and some of the issues involved with stringing them together. And then we talked about SCSI devices, some of the advantages of SCSI, and we also talked about some of the issues that people run into there with SCSI ID numbering and chaining SCSI devices together and the termination problem there. And that's just, it seems that always comes up when people are chaining SCSI devices together. Then we talked a little bit about peripherals, the various interfaces that are out there, what they're for. And then finally at the end we talked briefly about laptops and Linux. Well, guess what? Well, that's all, folks. That's it. Our video series on Linux is over. And whether you just want to run Linux on your home computer or you want to be the system administrator at a large Linux installation, I sincerely hope that this video series has gotten you on the way to fulfilling your goals, and I really thank you for watching.